Hey, chemistry. Hope you have had a great weekend. We are back today, continuing in chapter 12, still in 12b. And I'm going to take a minute actually to give you a couple of types of problems that are not mentioned in your book, but that are important. And those deal with dilutions. And we're still going to be dealing with molarity first when we talk about dilutions. And then we're going to move into molality, which is a little bit something different, but it's still dealing with concentration. Okay, so I'm going to just dive right into these problems because that's what today's lesson is going to be about. We're going to deal with dilution problems, and then we're going to deal with molality problems, two types of problems. So I'm going to go into present mode here. I'm going to pull up my PowerPoint for you guys. Let me go back. Sorry, hang on just a second. There we go. All right, so we talked about the idea of molarity, and that's moles of solute per liter of solutions. And remember that a solution is solute plus solvent, all of that together, that one volume is what we divide by. So moles per liter, if you don't have moles, but you have grams, you have to convert to moles. I hope those problems went well for you. If they didn't, you need to check in with office hours, okay? Now, sometimes, many times actually, you have to dilute a solution. So it's not the molarity that you need. So a lot of times, for example, I'll buy for the lab a 6 molar HCl solution. But sometimes my experiment calls for a 2 molar solution. So I need to know how to dilute that, make it less concentrated. And that's the type of problem we're going to look at first today, dilutions. Now, the nice thing about it is when we compare molarity and volume, we can use a rule that looks a lot like those gas laws. So remember P1 times V1 equals P2 times V2? Well, we're going to take that idea and incorporate it into using molarity and volume instead of pressure and volume. But guess what? The relationship is the same. So if you increase the volume, you actually decrease the concentration. So if I have a 6 molar portion of a 6 molar container, or in my container, I have 6 molar solution of hydrochloric acid. If I add water to that, I'm diluting it. So I'm going to be increasing the volume, but I'm just adding water. I'm not adding HCl. So I'm actually diluting the amount of HCl in comparison to my entire volume. So the idea there is molarity and volume are indirectly proportional. So the formula that you're going to use is the molarity of one solution times the volume of that one solution equals the second molarity, or the molarity of the second solution, times that volume of the second solution. And just like with the gas laws, you're going to be given 3 blanks, and you need to find the 4th blank. So you're going to be able to fill in for 3 of these, and you divide, multiply and divide to find the 4th one, the one that you're looking for. So let's just go right into an example, okay? So a question might read something like this. What is the final molarity if 5 milliliters of a 4 molar solution is diluted to 200 milliliters? So the idea here is that I have 5 milliliters, and it's pretty concentrated, it's 4 molar. And I'm going to dilute that so that the final volume is 200 milliliters. All right, so how would I fill that in? All right, I'm going to take that formula that I just showed you, M1V1 equals M2V2. And then I'm going to fill in. I've got 5 milliliters of a 4 molar solution. Okay, first thing I do, just to keep things normal, just to keep things, the idea of moles or molarity, you use liters. You have to be consistent here because this molar value is based on moles per liter. Now, I have milliliters for my volume. So before I do anything, I have to divide 5 by 1,000. So I get 0.0050 liters because I take that 5 milliliters and I divide it by 1,000 because my volume must be in liters because my molarity is in moles per liter. So I have to keep my units the same, okay? So I've done that conversion. My initial molarity is 4 My initial volume is 5 milliliters or 0.005 liters. I'm searching for that new molarity once I increase that volume. Now, what this means is I'm increasing the volume to a total of 200 milliliters. So what I'm really doing is I'm adding at 195 milliliters to this 5 milliliters. All right. And again, I have to convert 200 milliliters to liters. So I did that here by dividing by 1,000 to get 0.200 liters. All right. So just a reminder here, that's what I did. Notice that milliliters is converted to liters. Make sure you do that if you're given a volume of milliliters. And then I just multiply 4 times 0.005. And then I divide that by 0.2. And when I do that, I get a 0.1 molar solution. All right. Now, another way that this could be phrased is, what is the molarity of a solution if 25 milliliters of a 2.5 molar solution is added to 100 milliliters of water? All right, so I'm taking 25 milliliters of a 2.5 molar sodium hydroxide solution, and I'm adding that to 100 milliliters of water. So I've got 100 milliliters of water in one beaker, and I have 25 milliliters of my sodium hydroxide solution in another. I take that 25 milliliters and I pour it into my 100 milliliters of water. All right, so I have to actually add these two values to get my other volume. So my volume is not 100 milliliters. My volume is actually 125 milliliters. And again, these are milliliters. So before I start problem solving, I have to convert that to liters. All right, so I do know the molarity of my sodium hydroxide solution. All right, and I know that I'm taking 25 milliliters or 0.025 liters. All right, so 2.5 times 0.025 equals the new molarity. That's what I'm looking for. And then I'm multiplying that by the total volume, which is that 25 milliliters that I added to the 100 milliliters of water. All right. And then I just multiply 2.5 times 0.025 equals 0.125 times my new molarity, divide by 0.125 to get 0.5. Those are dilution problems, and those are some of the problems that you'll be doing for part of your lesson today. Now, the next part is on something called molality. So we had molarity, and now we have molality. So the difference in spelling is just that L instead of an R. The way we abbreviate that is actually an italicized lowercase m. Now, here's the difference between molarity and molality. We still have moles of solute. That hasn't changed, but we're comparing it to a kilogram of solvent, not solution. So the denominator is what is different. We're using a mass in kilograms. That's important. And then it's not the entire solution. It's only the solvent. And here's how you would use that, the notation for that. It's 6 lowercase italicized m HCl. And you would read that as 6 molal hydrochloric acid solution. All right, so again, there's the math. Moles of solute divided by kilograms of solvent, not solution. So it's only the mass of the solvent that goes on your denominator this time. All right, so an example of a problem like this would read, what is the molality of a solution composed of 30 grams of sodium nitrate and 400 grams of water? All right, notice I have 3 sig figs here, 30 grams, 400 grams, decimal point at the end, signifying that all of those digits are significant. So just keep that in mind as well. All right, so the molality, go back to the formula real quick as a reminder, moles of solute divided by kilograms of solvent. All right, I have 400 grams of water. That's my solvent, but it's in grams, not kilograms. So the first thing I'm going to do is divide 400 by 1,000 to get 0.4 kilograms. Okay. Now, go back again. I need moles of solute, but in my problem, I have grams. So I have to convert. 30 divided by the molar mass, which is 85, gives me actually, that is wrong. Let's do that quick math again. What is 30 divided by, sorry about that. Let's check that. 30 divided by 85 is 0.35. My bad. So 0.353 moles. All right, let me go ahead and subscript this too, so no one's confused by that. Goodness gracious. Okay. So there's my moles, and now I also need to delete the decimal. Great. And then, so that means that this is wrong. That should be 0.353. Which means this is wrong. My goodness. All right. So my moles, 0.353, divided by my mass of solvent, which is water. So when I do that, let me recheck my math there. Divide that by 0.4, and I get 0.882. And that's a lowercase m. I'm dealing with molality. And I will italicize that. Okay, you'll find with this video, you'll also find a set of practice problems. Please do those. If you need help, feel free to email me. You can talk to me during office hours. Same thing as last time. If you, formatting is really hard in Google Docs. It's kind of a pain to move around all those lines and get all that neat. If you want to do it that way, fine. I do want to see your work, so make sure you show me your work. So if it's much easier to print it out, handwrite it, take a photo, that's fine. I just want to make sure I see your work so I can help you understand if you are missing what you're missing, okay? I hope you guys are doing well. Miss you guys, miss seeing you in class. Hopefully it won't be more than another few weeks, but take care of yourselves, be nice to your parents, be nice to your siblings, and I will talk to you soon. Bye-bye.